Or like,
How do we verify that?
or like the student.
I think it's recording now. Yeah, it's recording. Can you help me with the PPT again? I'm not
Safari.
Can you also join in the meeting on your mobile so you get to know whether things are working the way?
Link
Yeah.
She didn't finish like the hard.
So yeah, to start again. Hello all and all the people online. So did you all get a chance to have a look at the first NLP workshop that was conducted last week?
Yes.
I saw the video, but I couldn't get where are the slides. I couldn't find.
You couldn't find the slides. Okay, so I'll post it in the Slack channel again. But yeah, so but you did see the video, right? Okay, and did you any one of you did try the assignment maybe? Nothing. No issues. So now when I'll be sharing the slide, you have the assignment posted in the slide, and you also have a solution linked to it. So what I'll suggest is you do try to attempt it first, and then whatever issues you have, you can contact us, or you can also have a look at the solution.
Will you be posting the solution or?
It's already posted.
Oh.
So in the slide, you have the question and you have a link to the solution. So, but yeah, of course. Oh, okay. You'll have to let yourself in come. I am bad with this.
Admit.
How does it go back to the like?
Or it have Linux ever. So sorry. After escape first.
Yeah. So so I'm going to assume that you guys have seen the last lecture, and that's where we are going to start from. So today's lecture, we are going to dive deeper into transformers and other aspects of NLP. And to begin with, in the last workshop, we had a discussion slide which we couldn't complete. So we're going to start with that. So first of all, to begin with, do you have any doubts or issues from the last lecture? We're good. Okay. So to begin with the discussion, so basically now what I'm going to show is there are a few NLP problems, or let's look at them as just tasks, and let's try to discuss.
Screen is not visible.
Screen is not visible.
Like the presentation is not visible.
Ah, okay. The screen sharing is paused.
The screen is shared. Yeah, now it's good.
So we'll start with the discussions now. So we have this issue. Okay, so you have been given resumes and interview transcripts. Please check how aligned the candidates are to the given role description. So with respect to what we learned the last time, what can you guys think about this question? So I'll repeat, we have been given resumes and interview transcripts. So this is, let's say we are like company here trying to hire people, and we have resumes and we have the interview transcripts. So how do you think we should approach it? Anything is fine. You can say anything that you like.
Can you repeat the question?
Yeah, so basically we are a company and we are hiring people, and so we have their resumes, and when we conducted their interviews, so we have the interview transcripts. Now we need to check how aligned these candidates are to the role description that we have. Also, we have a file in which we have role description. Yeah, that's a good start.
The role description.
Mm-hmm.
maybe generate like a calculation for like a transcript looking at the grades of their all version of the GPA.
Exactly. So basically, what in this one, what we'll be doing is that we'll be doing the complete NLP pre-processing. So we'll be identifying main keywords. We'll be trying to do similarity search. Sorry, rather we'll be doing similarity comparison. How similar is the resume with respect to the description? We can also do a sentiment analysis where we can identify how positive their interview was. We can do something like topic modeling to identify what were the main topics that these guys were talking in. Right. So moving on. So now Alpha International is expanding their business and hires many candidates every day. Employees being new have many repetitive questions like how to set up payroll and stuff. Please suggest a solution for this problem. Yeah. So Alpha International is expanding their business and hires many candidates every day. Employees being new have many repetitive questions like how to set up payroll, how to where's the company's cafeteria, something like that. So can we suggest a solution using natural language processing?
You pull out like all the questions that are repeated and then just answer like all of them in one.
True. So maybe we can suggest something like a chatbot.
Right.
So
To like help them with their research program.
yeah, exactly. So the reason being that these questions are repeated, so we can kind of guess what a new employee might think of, or rather what issues he or she might face. And to tackle that, what we can do is we can use a chatbot and something like, for example, something like ChatGPT, right? So where you just post questions and it has answers in the backend. So the way these chatbots basically work is at very high level. What happens is that whenever a question is entered, you do a similarity search with respect to all the questions that you have in your database. The question that gives you the highest similarity score, the answer corresponding to that is posted. And let us say you're not able to find a similarity score, in the sense you're not able to find a question that is similar to what the user is asking, then you usually post something like that. I don't understand this and please contact so and so person. Yeah. Do let me know if this is sounding too vague, because this is in line with what happened last week. So in a sense, so if you did go to the last week's lecture, then all this should make sense, like the concept that we're talking about. Yeah. The last one. So recently USG had conducted their elections, right? The undergrad elections. So now let's say you have access to all social media chats and posts regarding the issue. How can we predict the outcome of the election?
Look at each post to see if there's negative keywords or positive keywords for each, I guess, topic.
Exactly. So this is something in lines of sentiment analysis. So what we'll be doing is that for every post or every media chat that we receive, we'll first of all try to classify it as positive or negative, and then we'll identify who does so for example, Yash and Aditya both are standing in the elections, and we'll classify whether the post is for Yash or is it for Aditya, and then the positive or negative sentiment. In general, the person who has more positive posts rather than negative maybe will be winning the election. Of course, will be like 100 other factors to it, but this can be a start. So the reason that we have been discussing this today is because your project is going to be on these lines. So basically, we'll be trying to solve a issue like this. So what we need to understand here is, given any abstract question or any abstract problem in life, can we map it to a solution using natural language processing? So for example, if I say, try to identify who among these candidates is the most good looking. Can we do that using NLP? Not really, right? This is more of a computer vision kind of a question. And furthermore, good looking, what's the definition, right? It's pretty subjective. So given a problem, we need to identify whether natural language processing can be used. And if it can be used, then what are the main things that we're going to do? So if you remember from the last time, we had all these big things, right? We had topic modeling, we had sentiment analysis. So using all this stuff, what are the things that we can build? That's what we are trying to come up with. So have you guys thought of any project ideas that you would like to work on, or do you have any suggestions on that? Not yet.
No.
That's completely fine. That's completely fine because I get it. It's very abstract to start to just start with the project, but we'll be helping you with that. But what I want to emphasize right now is that it's time now that we start discussing on the project. So we'll be having
Also, in addition, like the project would be a combined effort. So you guys are not on your own and not like we're not going to help. So you can like approach us with any questions, and we'll also be going through some ideas which we have. So in the session, so you can pick them or like build upon them. And I think typical ideas that we need to come to one topic by the 31st, which will be next week.
So it's not gonna be like that, after this session. So today mostly will be the last NLP session. If we need it, we'll have another one, but mostly it will be the last. But it's not going to be like that after today's NLP session, we directly see you on 14th and we are like, show us what you guys have done.
No, it's not gonna be
It's
like
not
that.
definitely not gonna be like that. Definitely not gonna be like that. So consider it like a team project where we all are the part of the team. Yeah. So we all are going to do the project together.
But
So-
generally, we can choose anything similar to the questions that asked.
Yeah,
No,
definitely.
you can choose anything which is.
I'm just gonna use the restroom.
So we'll discuss on it. So like you said, right, we don't have any definite project idea yet. So we all will discuss on it what seems to be feasible, because if we to choose something very ambitious, it may not be possible during the given time frame, right? So we all will sit together, we'll brainstorm on it, and once we decide the topic, then we'll move forward from there. Yeah. So yeah, good. Let's move on. I think yeah. Would you like to continue, or have we yet to connect? Or?
No, I think we can just continue. We're not going to figure out the display.
Okay, so let's
Does
do
the
this.
current Zoom work for you? Or would you prefer?
If you guys could join the Zoom link.
So in our group, there's how many people? 13? Or is there only 14?
I think students there are about 5 or 6.
Should be around that, yeah, 5 or
Oh,
6.
so not everyone has the same mention, right?
It's not a one-to-one mapping. So it's like
So,
It's just, for example, on the NLP Explorer Slack.
Yeah.
Says there's 13 members.
Okay, so if your question is if you have like one-to-one math mentor.
No, I mean like group sort of.
Oh, so for the group,
It's including
so the
everyone.
13 is
Yeah,
including the
So
mentors.
is
Oh.
I guess it's
and
like
Kathy
6 of
and
us, 7 of us.
everyone.
the 5 mentors and Kathy.
So that's 6.
That makes it 6.
So I mean, we're at 7. We said.
I think we should go with 2 projects.
If all 7 of you are interested, we can go with 2 projects, which I would not assume everyone would turn up. So I would say like firstly like communicate on Slack and like voice out your ideas.
Just join the Zoom link.
Like probably check how many of you are interested, and based on that you can have like either one or 2 projects.
Okay.
Oh, so all of us. No, this is true. These are still. Is there just one person?
Yeah, or once you join Zoom. Like,
Which Zoom did you
mute your,
join? Did you join the
audio.
recent one?
That's one.
Oh yeah.
Yeah, we're sorry for not able to get the flavor.
Yeah. So yeah, are you guys able to see the screen?
Yeah.
Yeah. So this was the discussion that we had. And yeah, this is the project. This is the assignment. Yeah. So when you get some time, just go through this assignment. You also have the data set link and you also have the solution link. So in the solution link, it's basically, let me the solution. I missed screen is still visible here. You can see the code. Yeah. So you can play around with this. So basically what I've done is I've hosted that data set on my drive, and I'm just reading it through the URL. So this URL fake and path fake, and I'm just trying to read the data frame directly from the drive. So you guys don't need to download anything or anything of that sort. You can just directly plug and play. So you can just click on the link and start running the cells.
So before we do that, how comfortable are you guys with coding, like in Python?
Maybe a bit, yeah, something like that. Yeah, that works.
Yeah,
that works.
that works. No, you're not expected to know
Yeah.
anything. So I just wanted to know so that like we could frame our problems accordingly. And I think regarding the solutions, like we can. So in case you guys want a run through of basic Python, again, we can do that. Yeah, just let us know.
Or I guess, because we have access to the other.
Videos.
So
Yeah.
I think that's fine.
Yeah. If you could go through, then it would be actually good.
Yeah.
Yeah. So I guess then we'll start with today's session. Okay.
Yeah. So we'll go through the project ideas maybe later on. No, we'll go through that later on. You can start.
So I start with a very brief. Whatever a NLP engine is, right? It's pretty similar to any ML component that goes in, right? You collect your data, you do all the pre-processing that needs to be done, you create a model out of it, and you get your model to.
Do you start all your video?
Should I?
Yeah, I guess you should. He'll mute.
Yeah. Hi, folks. I'll start over again. So any traditional NLP model, right? If I give you any specific task right now, if I say you'll have to do text summarization, what you have to do is like if you just visualize the whole process, it's gonna be like you have let's say a paragraph, a lengthy article, news article, and if you have to summarize that thing, right? How would you do that? So how it starts is you gather lots of news articles because you eventually have to train your model, right? So you gather a lot of data, you pre-process. So by pre-processing, I mean you'll break them into single words, which we call tokens. You then go ahead and like remove all the stop words, which are not necessary for all the analysis that needs to be done. So there are a lot of pre-processing steps that come into the picture, right? Once that is done, we can do feature engineering, which is basically we can manipulate data, right? We can use whatever the data we have to, let's say, if we want to like make composite words out of them, depending on whatever the use cases, right? This is a normal pipeline, and then we create a model out of it. Let's say we try 2 or 3 different models, and which one gives the better accuracy, that's what we choose. Now this is fairly simple and it's pretty straightforward if the let's say if the use case is not very complicated. But now if I'm talking about, let's say something called as BERT or a chat GPT, their use case is really huge and it's like it deals with real world applications. So it's not possible for me to always go ahead and train data every time. And that's the part where like traditional NLP pipeline is like it's more challenging, right? Can you just move to the next slide? Yeah, this one. So that's the pitfalls, right? As I said, if you want to create a really complex data model, it's not really feasible to always train the model and you know evaluate the model and then eventually use it. Because like it's very expensive in general, right? If I tell you right now that if you have to go ahead and create a model, the first step is you have to collect data and manually label it. So that's really expensive and it's like labor intensive. Just to give you a small example, GPT-2 cost 1.6 million just to train. So that's how complex training could go. Secondly, not everyone can create those complex models, right? And that's why such models lack semantic understanding. So what I mean by semantic understanding is like, if I'm saying like I want to create a use case wherein I want to predict the next word in a sentence, um, I need to know the context of the sentence that it's coming from. So it's not very easy to create such models, and traditional NLP models cannot do that. But like existing models, they have something called as semantic understanding. So they understand the relationship of the words in the sentence, and they can get the context of the sentence. And then probably based on whatever the confidence of each word is. So confidence is a metric. Whatever words they have in their vocabulary, the one which has the highest confidence, that's the next word which is used as the predicted word. Secondly, as I told you, like it, can we just close the door? Okay. So there's also a thing wherein like we need large scale label data to train such models, and usually for NLP labeling has to be done by humans. So imagine like you have 2 million, 3 million rows of data. It's not feasible for a researcher if he's like dangling between 2 or 3 ideas to always label that data and try out different methods. And the last one is like it lacks domain generalization. So what I mean by this is, assume I have two applications. One is sentiment analysis, and the other one is Q&A. But like if I want to run two different applications, I need to train two complex neural networks here just to get both of them working. But assume there's a general model. I have a general model, and if I can tweak a little bit in that particular model and use for both of them, so that's like I have this model that's generic to different domains. So it could be a Q&A model, predict new word model, sentiment analysis, text summarization. These are different domains. And if I have a common umbrella, and if I make certain changes in that umbrella model and use them for all of the domains, right? That's called domain generalization. So it's not possible with traditional NLP to do that because I have to train separate models for each domain. That's the pitfalls for traditional NLP model. So the next slide would be transfer learning. So this is where the major part comes in. Like this is where basically researchers and companies, they come out as smart people, right? They don't train NLP models for every different task. As I said, there's a general model, and they fine tune certain aspects of the layer. So to give you an example, let's say I have a chat GPT, and if I remove the last layer of that neural network, and I probably replace it with a new layer and train only that specific layer. I don't train the whole model because like the model could have like 1,000 different neuron connections, right? And there could be like, I don't know how many different layers of neural networks. So I just remove like the last layer and put in my own layer that fits my custom layer, and I just train that part. I don't train the rest of the part. And then I use the whole model now to say use for text summarization, which by the way is possible. So if I do that, I'm not only saving on cost, I'm also saving on human effort, and I can try out multiple things, different ideas for my business or for my research, which also helps me save time. So using that one specific model, I can do that. And the process of doing this, it's called transfer learning. So rather than here's the dichotomy, right? It's not just fine tuning and training. These two are completely separate domains. If I talk about fine tuning, it's just taking the last layer and training the last layer, but I use the whole model. If I say training, I'm training the whole model through and through. So that's the difference between two of them. Just to give you an example, fine tuning would be just replacing a Spark plug in an engine. But if I have to train the whole model, I'm like, I want to replace the whole engine, which is a very laborious task. And it's always, again, it's expensive. And as I gave you an example, right? One of the examples of transfer learning would be, let's say I chop off the last layer of word predictor, and then I introduce a new layer. And I just train this specific layer I can have a completely different model, and that can be used for sentiment analysis now. So you see how much more like I become, let's say if I'm a business, right, and I have a competitor in place, and if we're both trying to target say uh, a complex application that works around sentiment analysis. If my competitor, he goes out and tries to create the whole NLP model on his own, he would take around 3 months, excluding all the money and everything that goes into the aspect. If I be smart about it, and if I just take a pre-trained model that has like complex neural network, and then I just like make certain changes, and within 1 month, like, and 1/10 of the cost, if I can get that application running, that's smart of me to do that, right? And I can, like, even if the first doesn't work, I can work on multiple ideas in that particular 3 month. So that's what transfer learning is basically. So yeah, and then comes our modern NLP pipeline, which is an extension to the idea that's being discussed right now. We collect our data, and then we used a pre-trained models, which with a little bit of fine tuning in place. We don't do all the feature engineering, the what do you say, pre-processing and all those things. We just use the pre-trained models, and then depending on different pre-trained models, we find which gives us the better accuracy for our data or for our application, and depending on that, we deploy it for our business needs. And the good part about it is, like, can we move to the next slide? Yeah. The good part is that we already have trained models which have been trained on a high, like a huge parameter size. So we don't have to go through the part of training it, and we obviously save a lot on computing power, right? um, Again, like, for it's very good for researchers and businesses, because like it helps them try out their ideas really quick and do all the trial and error, and then eventually find what best suits their use case. Then we also, like, one of the needs for this is like it allows us to do embeddings for downstream tasks. So what I mean by embeddings here is, like, words are converted into lower level numerical representations whenever we are like working with NLP data. And those numerical representations, they are fed into our models, right? So those are called embeddings, the numerical representation. And downstream task is what is my specific task. So sentiment analysis is one downstream task. Q&A would be a second downstream task. Text summarization would be third, right? These are downstream tasks. So these large models, like, they can, as I said, they can, with fine tuning, if they're used for different specific tasks, that's called like providing embeddings for those downstream tasks. So we have that with pre-trained models. And then some paradigms of them would be like mass token modeling and next token prediction. So by mass token modeling, I mean, like, if it's like fill in the blanks, right? So if I want to, again, it's like you have a word, and then I just leave one of the words completely blank. So if I have to predict that word, or if I have to just predict the next word in the sentence, all of these kind of paradigms can be easily done with pre-training. So that's the part from my end. You might want to take on. Oh, by the way, any questions, guys? Oh, okay.
Yeah, just feel free to interrupt us in between and ask any questions you might have. So now, like, yeah, we just talked a lot about like pre-trained models and stuff. So what are these models? Like, okay, we just made some claims. These can be easily extrapolated to downstream tasks. You can use them without a lot of uh, training data. So these would require some capabilities. And so when I say capabilities, so what do you think would, so you as a human understand language, and what do you think are the fundamental things you need to know to, say, understand some sentence? So let's say I have this sentence. I am writing a paper and I'm extremely stressed right now. So what do you think you need to understand in order to get the context out of it?
You definitely need to know the subject for one.
That's a good start. You need to know that, okay, there's this person.
Yeah.
And so do you think that, let's say if I mask out the word stressed, so if I just say that I'm writing a paper right now and I'm really dash,
Yeah.
so do you think you can infer that it's stressful?
I don't think so, because in my head, maybe you're extremely happy writing this paper. I don't know.
That's true. So here in this sentence, you're lacking that context. So if you mask out the word stressful, you just lose that. So what these models are trained on is, so let's say you have like a bunch of data. So you just scrape the internet and you just scrape the entire of Wikipedia. And now you want to build a model. Oh, is it better now? Oh, yeah, sorry for that. Yeah, so let's say that you just have a bunch of data. I just give you a bunch of data and you want to train a model such that it understands, it is able to find these, it's able to fill in the blanks. Like, any ideas how you can do that?
How you can do it.
Reddit fill in the blanks, or how would you even start thinking about it? Yeah, how would you do the pre-train?
Would you have to fill it in? Would you have to give it information about Serena Williams? Or what if it's Serena Williams plays tennis? Would you have to then give it like a lot of information about Serena Williams?
That's one way of doing it.
Have also like a separate like possible for method extract.
So it would more be a rule-based method.
So like find like the, I guess, what specific part of speech could be like the subject for whatever.
So you would want to, like, given a sentence,
Right.
classify, okay, this is the noun, this is the verb,
Yeah.
this is the adjective, and based on that you would kind of have a rule based. Yeah, that is one way of doing it. But if you would want to do that, you would end up with a lot of possibilities. Like, you would have to list all the verbs, all the adjectives, all the nouns, and things like that. And you would also have to establish this notion of which nouns are associated with which verbs. So what people do instead of that is, so let's say I have this. So are you guys familiar with probability? No, that's fine. So when you think of probability, just think of, just think of it as chance. So let's say you're given this sentence. So what do you think are the most likely words?
Real.
Yeah, so they could be maybe not so much. Each could be one of it. And so what these models are trained on is, you just mask this out. So let's just say. So you just mask this out, and then you have this. For now, let's just say this is a black box. You just feed this in, and then at the output, you would predict which word this is, which it is more likely to be, and then you want it to predict road. So since you already, you wanted to predict walking. So this is known as self-supervised supervision, because so let's say generally you would have an input and an output, whereas here you just have an input, and this you're trying to get your output from the input. So this way you don't need to have any annotations, you don't need to have humans sitting there and figuring out, okay, what is the output for this. So the self-supervised methods, they kind of reduce your these do not solve your downstream tasks as such, but they help these models get an understanding of semantics. And yeah, so as I was talking about, this is this paradigm of, say, in the input, you just have a mask and you just pass it to the model. And then at the output, you just predict whichever has the highest probability. That is known as masked language modeling. And just to illustrate, so here, can you still see the screen? So here in the input, I just give it, okay, the largest mask on the planet Earth is the blue whale. And you would expect that it would return mammal. And as you can see, once you, at the output, if you see what the decoded token is, it's a mammal. And so this model is known as BERT. Yeah, it's full form for bidirectional encoder trained transformers. So yeah, you don't need to remember it. This model BERT, it's trained on the masked language modeling. And in addition to that, it's trained on next sentence prediction. So what does this next sentence prediction task do? So let's say that you have two sentences, and 50% of the time you just give two sentences which follow each other, and 50% of the times you don't give sentences which follow each other. And at the end, you kind of predict if these sentences follow each other or not. So in this way, you're just giving more information to the model of sentences which can go alike and sentences which do not go alike. And so this type of training is useful for question answering, as you can probably imagine why it would be helpful for question answering, because you want to know like which sentences go along and which sentences don't. And now what is next token prediction? So next token prediction is basically it is the, so your next token predictor just predicts the probabilities of what can be the next token given your past. So let's say I have this, I have another sentence. So given this, you just predict what all could be here. So these could be like any food item. Like it could be a pizza, it could be a taco, it could be anything. So you train your model such that you minimize your loss function for all the food items. And so this next token prediction is generally useful for generative models. So when you say generative, your ChatGPT or any other language model, you use this, and this is kind of an autoregressive method. So when I say autoregressive method, you just you input this, and you predict this, and then you input these two, and then you try to predict this, and then you input these three, and then you try to predict this. So at any point of time, your model just has whatever is to the left, and it does not have anything to the right. So this is more kind of how humans think. Like you just think of, like you don't, when you're uttering a sentence, you don't think of what are you going to talk like say a sentence to the right. You just think of, okay, what am I going to talk sequentially? And yeah, so what is our objective? Like by LLM, so LLM is just short for large language models. Why are they gaining so much attention? What these models are and what these models aren't. So firstly, these models aren't magic. This is just a image of like all the scores which maybe an entity got. Any guesses of what it might be? Yeah, they're the percentile, but who got all of these, right? Like they look pretty good, right? Like if one person can get all of these, you would say that that person is pretty good at.
Just a hint, it's none of us. What's the biggest thing that's in there in the news these days?
Mm-hmm. Yeah,
Oh, you saw these are scored in the chat.
yeah. These are the scores of, yeah.
So- ChatGPT did all these tests, or they're just comparing them?
No,
Oh,
they GPT took all these tests.
Got you, AP.
they suck at it. Sorry.
Yeah. So, I mean, there should be some reason why it's doing so well, right? There should be like it's just not like, yeah, people just it's just not luck. So, what are these models? So, as we previously said, these models predict the future tokens given the past. So when I say past, like okay, given an input, they try to predict whatever is the next output. And one thing to remember is these models have a fixed vocabulary size. So when I say vocabulary size, they so when you think of it, like, do you think that you can have all the words in English dictionary as the vocabulary? All the words in English as your vocabulary. Do you think that is feasible? No, maybe not, because firstly, the vocabulary is increasing every year. And secondly, it would be probably like a few millions. And that is computationally not feasible. So what
these models use is they use subword tokens. So for instance, you take lots of data, and then you say that you fix the vocabulary size you want. So let's say you just want 10,000. You just want your vocabulary size to be 10,000. So you run through all of these documents and figure out what the best way of representing them would be. So let's say I have a document which just has A's. So I can just represent it with two tokens, right? One is the space and the other is the A. But instead of that, let's say let's say I use just if each token I have is the English alphabet, are the English alphabets. So I can represent it using like 26. But what do you think could be the issue when you use only 26 alphabets as your tokens?
You're also using special characters.
Okay, let's say I use all the special
Okay, sorry.
characters, all the alphabets. Is there any issue? Like if you token the word, let's say, so let's say you use only the alphabets. What would the tokenized version of the word walk be? It would be W, A, L, and K. So what are you missing out here? Like, are you missing out on something? Like we are individually chopping each word into.
You're missing the meaning.
Precise. So you're missing out on the meaning. So you wouldn't want your tokens to be as small as like every character. You wouldn't want your words to be as abstract as each word. So what I don't want to get into a lot of technical details, but let's just say that you find you just optimize it such that you find subwords. So like
Oh, so like if one word has a Y ending or something, or a pluralization, you would cut that out and only take the.
Yeah, that is one way of doing it.
It's like, wait, is it you're taking each character individually, so it really has to be?
Yeah, if you take each character individually, you lose the meaning of the word, right? So you don't do that. So let's say you have the word concatenate. You would break that into concat and NAT. Or if you have some word like beautiful, you would probably break it down into PEAUT and FUL, because FUL occurs in a lot of other words. So it might be better to represent. But nowadays, people don't you don't manually do that. You just have an algorithm which kind of finds the best tokens which you can use.
Okay.
And another point to mention is that you cannot give as many inputs as you want to the model to these models at a given time. So ChatGPT has a word limit of 2000. So it cannot take anything more than 2000. So the reason why it performs bad on AP English is because it cannot generate long form sentences. And yeah, and nowadays people just come up with any number of parameters, 560 billion, 150 billion. It's just wild. And so how do you train them? As we previously talked, you just train it on this next token prediction. And in case you don't understand, if you have not taken a probability course, it's fine. You don't need to understand them right now. But just remember that they're trained on next token prediction. That's about it. And these are some of the notable LLMs. You can just search about them later on. And yeah, so this is what we are most concerned about. How do we use them? Yeah, can you just read this problem and maybe figure out the answer? I didn't expect it would take this long. Did I make the question wrong? Yeah, I'll just wait for a minute more. Do we have anyone who solved it, or do you have any guesses?
Would anything like all three?
Yes, that's correct. It's just 100% because it's just doubling every day, and and yeah, you can just look at the response which ChatGPT gives, which is it doesn't solve it.
It doesn't?
However, you can say that.
Oh, it's supposed to be
Oh,
not
okay.
full.
So it misunderstood the question.
So it's not all doom and gloom.
Misunderstood.
It's not going to replace any of us anytime soon. So
Let's hope so.
yeah, so yeah, that was on a funny note, but let's just see like what it can do, what it can't do. So did you guys like play around with it? Are you already using it? So this is one prompt I asked it. Like I just said the emotions to be happy, sad, surprise, joy, disgust, anger, and you just ask like what are the emotions expressed in the sentence? Do you think it's doing a okay job? Yeah. So this is one emotions are something which GPT kind of struggles with, and yeah, it cannot really perform it well. And people have tried like a variety of things to make it um, better at detection of emotions. Like what you could try is give it definition of happy, definition of sad, definition of surprised, and then try if it does any. Yeah, surprisingly, it does know that you can't integrate sin x by x. And yeah, this is another example wherein I just so what have you guys been using it for?
Using for,
Mhm.
um, I don't know, so,
Yeah, so I was just struggling with this code to so this I just wanted a code which kind of multi-threads stuff, and it's pretty impressive. Like you can just copy this and it works. So, so yeah, you can just play around. if you guys want access to this new thing by Google, just let us know. We can get access to it. So, yeah. And I mean, this sounds tedious, right? Like you can't just go like if you want to do some research, you would not want to go in and type every single time what you want to know. So there's a better way of doing it. Yeah, you have any questions?
Oh, actually, we have to email you if you want to get access to our.
But yeah, if you guys want it, I can ask. Yeah, just email me. We'll, we can probably get it. We should be able to get it in most cases. So do you guys have idea of what an API is? Or yeah. So OpenAI has these APIs available, and you can just use them out of the box. And I think we'll just go how to use them. And in case you guys decide to use them in your project, we can get some credits for that. So when I say credits, it's like you need to
access.
Yeah. Yeah, so in order to access it, you need two things. One is your access key, and the other is your organization ID. We can, in case you guys want to use it, I can run through like how you can create a key and organization ID. Yeah, don't share your keys with anyone. That is what I would say. So how do you use it? So you just install this package called OpenAI. So you would do your pip install OpenAI, and so are you familiar with pip? With installing packages in Python?
Yeah.
Okay, so this is how you install. So Python comes with a set of packages, but then you have this huge open source community, which kind of writes packages which you can use. And if you want to install them, you use this command pip install, and then you install whatever name you want, and you can just install that. And once you install that, so you can use it like any other Python command. So, and if you want to use that, you just say, okay, import that package. And so this is just, you're just setting your organization ID and key to specify whatever you have. And here you just have a query like, what is OpenAI? And you want to get a reply to that. So you would use the chat completion feature, and you have a bunch of models which you can use. For now, I would say like use the GPT 3.5, so which is the chat GPT output. And so you can see this feature called temperature. So temperature is basically if you set temperature to 0, it will just give one constant answer. Whereas if you set your temperature to some other number, let's say 0.1, 0.2, as you increase your temperature, it starts giving variable answers. That is like, if you ask it what is OpenAI wants, it might give you one answer. If you set your temperature to 1, then if you ask it again, it will give some other different answer. So if you want a constant reply, just set your temperature to 0. If you want a variable one, just set it to some other number. And so here max tokens is the maximum number of tokens you wanted to use to generate. So yeah, this is the output it gives. Like OpenAI is an artificial intelligence research lab consisting of for-profit, and it gives a bunch of information about what OpenAI has. So do you think you can perform sentiment analysis with this chatbot? Or how would you perform sentiment?
With the chatbot?
Mhm. So let's say I have this input, like I'm extremely happy.
Mhm.
And you would want it to answer either positive or negative. So how would you frame your input such that it gives what about what you want? You just ask it.
Oh, literally just.
Yeah, you just ask it, what is the sentiment of the following sentence?
Okay.
So if you can see the query, like, is the sentiment of the following sentence positive or negative? I bought a pair of shoes yesterday. They were so worn out and single use. I can't believe that. That would be negative, right? It would be a negative sentiment. So you just send this query and this is the reply you get. So now can you see why these pre-trained models are more useful? You can
a lot of the work that we have.
you can kind of perform a lot of tasks without explicitly training for sentiment analysis. Like if you looked at the previous week, we had to use one model for sentiment analysis, another model for emotion recognition, another model for text summarization. But here, you're just using one model and you're just varying your inputs such that you get the output for that specific application. So what do you think is the most important? Why do you think we're able to do this? Like, is it something about the data? Is it something about the model? Is it something about the way we are training it? There are no wrong answers. So it's a mixture of all of these. So when you come, firstly, let's talk about the data. So in these models, since you don't have any output, so you don't need any annotations. So you can literally take everything on the internet and train it. It's simple, right? Because you're just training it for the next prediction, the next token prediction. So what you do is you just take input of one sentence, you have the next sentence already there, so you just use that as the output. So you can train it on huge amounts of data, and at the same time, you can use huge number of parameters. The reason you can use these huge number of parameters is because you have huge amount of data. So you would not overfit. And at the same time, you have enough compute power now. And when these traditional models were being developed, you didn't have so much compute. It's as plain and simple as that. So these ideas have been there for a long time, but it's just that you now have the compute power to realize. And yeah, so how do you perform this on a data set? So again, you have these modules called dataset. So now we are just loading this dataset called IMDb. So it's just a bunch of reviews which people leave out. So on movies, like, okay, this is the best movie I've ever seen. I mean, they're not as simple. So as we can see some of them, they are pretty complex. Like they're not one sentence, they're like multiple sentences, and they do have some nuance to them. Yeah, so this is this is one of the review. So as you can see, if you had a model which did not understand semantics, you have this word, I love sci-fi and I'm willing to put up with a lot. So you have this word love. So if you're just predicting based on words alone, there's a possibility that your model gets confused because it has love. So that might be positive. And more often than not, you'll observe that a lot of sentences will have positive words. For instance, if in this sentence, I love sci-fi and I'm willing to put up with a lot, there are no negative sentences. There are no negative words as such. But when you read it, you know that it's a negative sentence. So why do we know that? Because we understand the context of it. We understand like that putting up with a lot despite loving it implies that there is some nuance here. So if you just use maybe a normal bag of words or other methods, it can't understand that. And yeah, I just won't go through the entire process. I think we'll just share the links with you. And here, yeah, as you can see, they are pretty good. Like, so see here, 0 implies negative. So it does more or less a good job. So what can we use them for? We can use them for a bunch of tasks. As we saw, we just saw it for sentiment analysis. We saw its usage for emotion recognition. And yeah, we can do it. And these are some open problems. So one of it is understanding bias in large models. So when you say bias, so for instance, does it treat men and women equally? So here, as you can see, like when you give the input as the man is performing a surgery, it assumes that it's a doctor. The man is a doctor. But when you ask it a woman, it says that's a nurse. And when you prompt it what the man performing surgery is, it says that it's precisely leading the operation. Whereas when you ask us like the woman performing surgery is, it would give something like carefully assisting the doctor. So, and since these models are being like deployed in the real world, you would not want these biases to be affecting them. So that is an open problem. Another is privacy leaks. So if you can see the picture on the top, you just give a random input, which makes no sense. And it starts giving out like your address or personal information. So that's pretty scary. And you would also want to detect which content is generated by these models, right? Because, so let's say you can easily create fake news. Like you can create articles which are pretty convincing that they are real. So you would want to detect that. And yeah, do you have any questions? No, that's fine.
For the board thing,
Mhm.
that's similar to chat. What would we be using?
Oh no, it's just for your exploration. No, so regarding your project, I think the best way would be to you guys. So do you know them or?
Yeah, well, I know Valeria.
Okay. So maybe talk among yourselves. Think of a few ideas. So one idea, so a few ideas which we had were so there are these embeddings called what there's this embedding called word2vec, wherein you kind of map all these words into numerical representations. And so one idea is to analyze if these numerical representations change across time. For instance, like say if you train it on some scripts from the 1970s and you move on to 1980s, 1990s, and the 2000s, like are there any changes? So are men characterized as certain way in the 60s? Are they characterized as something else in the 80s? And you can come up with some interesting analysis if that is something which interests you guys. And the other could be like trying out emotion classification or like probing these large language models. So it depends on you. Yeah, I think the best way would be to start a discussion on the Slack channel.
So that's Slack.
Mhm. Yeah, that would be it from our end.